Guys, welcome to Logic Bytes by AK. So, if you are searching for a solution to find a flips, minimum bit flips to convert a number, I'm sure that you are in the you have chosen the correct video. So today we are discussing a solution for the minimum bit flips to convert a number from start to goal, right? So we have our starting number as 10 and our goal number is 7. So how many bit flips do we need to convert 10 to 7, right? So let's represent 10 in a binary form as 1010, right? And the goal number, let's say we have 7 as 1011, right? Sorry. For 7, it will be 0 1 1 1, right? The goal binary representation. So we have to convert 1010 to 0111, right? So let's understand this example and the solution for this problem in a detailed way. So let's say we have our 10, which is our starting, and we have to get 7, right? So let's represent both of them in binary form. So we have 1010 as binary representation for 10 and 0111 represents 7, right? So how many minimum bits we have to flip is the flips, the different bits, the bits which are different in the same position, right? So at this position, bits are different, right? So we need to flip one of them. So here we flip one, right? So if they have the same bit, we don't have to flip them, right? So we skip that part and we have to get this, and this should be flipped and this should be flipped. So the total flips would be 3, right? So the first thing we have to do is find the bit positions where the bit values of both numbers is different, right? So here 0 1 0 1 1 0, right? How can we get that? So let's say we have our XOR operator, right? Which gives us, if they have same value, the result would be 0, right? And if we have two zeros, the XOR product of two zeros would be 0. So if we have different bits, let's say 0 and 1 or 1 or 0, which both end up with giving 1, right? So let's say we find 10 or 7, which end up with getting 1011, right? So we have 01, which end up with 1, 11 end up with 0, 01, 10 end up with 11, right? So in this XOR product, find the number of set bits. So the number of set bits is 1, 2, 3, right? So if we find XOR product for starting and a goal number, and we have to find the number of set bits. How can we find the number of set bits? So we have many solutions, right? So let's say the first thing is we iterate, we check every bit position, right, from 0 to 31st bit position. If that bit position is set, we increment our count variable, right? How can we check that bit position is set? Let's say we can get the bit value by right shift, right? So let's say uh, we have a number x and x right shift by 2, which resulting giving the second bit position value, right? So if it is divisible by 2, which gives us it is unset, right? So 0 is divisible by 2, which gives us which is unset bit. So if it is not divisible by 1, which end up with set bit position, right? So we can do that. Or else there is another solution to find the set bits, which is we reduce the number to the, I mean, we can directly iterate over the set bit positions. Let's say we have our XOR product as 1101, right? So what is this number represents? The number represents 1 plus 4 plus, and this one. So yeah, we have this shortcut with let's say we have this as n. We replace n with and the product of n and n minus 1. So this will end up with uh, number of iterations, which gives us only the number of set bit positions. So how many times if this operation executes, I mean, so we do this certain number of iterations up to where n is equal to 0, we stop that iterations. So up to the total iterations represents the number of set bit positions, right? So you can understand by taking an examples and perform the using pen and paper, perform this operation on the example of this number, this XOR product. You will get a certain number of iterations, which are three in this example. So you will understand the workflow of this statement, right? So let's code it now. So let's say we take XOR product. Let's say we take int XOR product equal to start XOR. Good. Now do we need a number of flips, right? Let's take flips. So we iterate over XOR product, right? How many times we iterate until the XOR product is greater than 0? If it is greater than 0, flips plus equal to 1, and we update with our XOR product, which is XOR product and XOR product minus 1. So this will end up with iterating over only set bits. So and then we just return the total flips. Let me just run it and then submit the problem. Yeah, here product again. Yeah. So guys, and I am also doing a playlist on dynamic programming and top 150 interview lead code solutions. So if anyone interested, please check out the playlist. I will provide the links in the description. So please share to your friends which is content if you feel that content was good. It could helpful to them. And thanks for watching. Yeah, that's it for today, and see you in another video.